Hi class, this is Mr. Morris again. I'm making an ideal gas law video. So if you just follow along, work through the problems with me. First of all, it relates pressure, volume, moles, and temperature in and T. And again, that's amount, and we're going to be dealing with amount in terms of moles. Our equation is this one right here, the PV equals nRT. By far, this is the most common form of ideal gas law you'll be using. And this is our constant. So where you see R, this is what it means. It means this number, 0.0821, and it's liter atmospheres per mole Kelvin. So because the units of R are L, ATM, MOL, and K, so liters, atmospheres, moles, and Kelvin, pressure has to be in the same pressure units we have up here. So pressure must be ATM. Excuse my writing a little bit. Okay. The volume, again, because of the units listed above, the volume has to be liters. The N has to be in moles. And the T has to be, the temperature has to be Kelvin. It can't be degrees Celsius. Okay, we're going to come back to this part down here. Basically, it just says that if I'm looking for density, we can rearrange it and we can find density using this formula down below. I'm not quite ready to get into that yet. Let's go through an example problem that just talks about the ideal gas law. So just this first example problem we have down here. All right. So it says calculate the number of moles. That's what I'm looking for of a gas. It's important to know the state of matter. Later on, that'll become more important. But it's moles of a gas that are contained in a 3-liter vessel at 300 Kelvin with a pressure of 1.50 atm. You notice that none of these values are actually changing. Let's go back up for just a moment. None of the values are actually changing. Well, if you look at our formula, we don't have P1, V1, P2, V2. We don't have anything like that. This is just one of each, one volume, one pressure, one number of moles and temperature. Okay, no changing values, and there's a reason for that. In this question, we don't have anything changing. We're just trying to find what's the number of moles if we have 3 liters, temperature 300 Kelvin, 1.50 atmospheres. So it's a little different than the other laws we've dealt with because of that. We're going to write down our variables or our values. PV in RT. It's one of these that's always going to be the same, and that's R. Again, it's called a constant, so it's always 0. Well, I don't know why it does that sometimes. 0.0821, and the units are liter atmospheres per mole Kelvin. That's the one that we always know. Gas law constant. Pressure was given to us 1.5 atm. Volume is 3.0 liters. The number of moles is what I'm looking for. I don't know it yet. And the temperature is 300 Kelvin. That decimal at the end is not a typo. Remember, it tells us that we have 3 significant figures. So as I type this out, it's going to be PV equals nRT. So PV is the first factor on the left side of our equal sign. So we're going to do P times V, 1.50 times 3.0 equals, and then we have nRT. N is my unknown. R is 0.0821. PV equals nRT. I want to solve for n, so that means I'm going to have to divide by these numbers combined. It's easier to go ahead and just multiply these and then multiply those, and then we're going to divide them. So on the left side, when I do 1.50 times 3.0, I get 4.5. Equals, and then n times 0.0821 times 300 gives us 24.6. 24.6, and I'm still multiplying by n, so use n. Okay. I want to n by itself so I can solve for it. I'm going to do 4.5 divided by 24.6. So n equals 4.5 over 24.6. And you get 0.18 moles as your answer to this. And that's what I was looking for, was the number of moles. All right, we've got one more down here that we're going to do before I call it a day with this video. How many grams, or before I wrap up this video, how many grams are present in a sample that has a molar mass of 70.0 grams per mole, and it occupies a 2.00 liter container at 117 kPa and 35.1 degrees Celsius. How many grams are present in a sample that has a molar mass of this and occupies that? Okay, so let's start out. It doesn't ask about density, so I'm not actually, this is not a question that's involving the other equation. It's just got an extra step to it. So I have P, V, N, R, and T. Again, we always know that R is going to be 0.08. Liter atmospheres per mole Kelvin. Okay. Temperature is 35.1 degrees Celsius. Don't forget, if you have Celsius, you need to add 273.0. And you'll end up with 308.1. Okay. N, I don't see N, so I think I'm maybe looking for that. Volume, 2.00 liters. And then pressure is 117 kPa. Because our units here are liter atmospheres per mole Kelvin, I need to turn my pressure into atmospheres. So we're going to do dimensional analysis here. I got to put kPa on the bottom, 1 atm on top, because there are 101 points in 1 atmosphere. So we get 117 times 1 over 101.3 and end up with 1.15. Atmospheres. So we got a couple conversions that we've got to do there. Now keep in mind, don't forget, it says how many grams. It doesn't ask me how many moles. So whenever I find moles, I'm going to have to convert them to grams. Okay. Sorry, we had a glitch with the microphone for a second there. PV equals nRT, so we're going to do 1.15 times our volume, which is 2.0. 2.00 actually, for 3 sig figs, equals N, our unknown, times R, 0.0821, times T, which is 308.1. We want to this a little bit. 1.15 times 2.00 gives you 2 equals, and then we have n multiplied by these numbers, 0.0821 times 308.1, 25.3. Actually, let's go with 25.3. That'll be fine. 25.30 actually, to keep our sig figs consistent here, times n. And if I want to solve for n, I need to divide by 25.30. So n equals 2.30 over 25.30. So let's see, n equals 0.0909. 0.0909 moles. Remember, we're not done yet. I've got to convert it to grams. So there we go. 0.0909 moles. I need to turn it into grams, so we're going to have 1 mole on the bottom. And then on the top we have grams. Well, where does that number come from? Well, it gave us the molar mass right up here, 70.0 grams per mole. We're going to use that. 70.0 grams in 1 mole. And you end up with 6.36 grams. I hope it's helpful. Work through the other examples and make sure you answer questions as you go along.